Yeah, like I have pasted the link in the chat box and as well as in the calendar for the today's live session. Is my screen visible?
Yes, ma'am, it is.
Yeah. Okay, we are in the week one, and today is the first session of signals and systems, week one. And so
Yes.
today we'll be discussing what is signals and systems, and we'll be having how to represent the signals and basic discussion of that we'll be having. And before that, I would like to know the schedule of this. Like it is uh, signals and systems live sessions will be having on Monday from 10 to 11 a.m. On Wednesday we'll be having it will be in the night from 8 to 10. Is my writing visible?
Yes, ma'am.
Yes, ma'am.
Yeah, okay. And another is on Saturday, which is from 9 to 10 a.m. So the course instructors for this signals and system we are having four. One is Vishal sir, one is me, another is Ankita ma'am, like she is in the session now, and other is Akanksha ma'am. Like yeah, Ankita, you can intro yourself.
Hello everyone, I am Ankita Patel. So I will be your instructor for this course Signaling Systems, and I highly recommend you to join these live sessions and clear whatever doubt you have. Please try to join the session after watching the videos and then get all of your doubts cleared here. Don't hesitate to ask. All the best.
Yeah, okay. Like so, do you know the grading policy for signals and systems? Have you gone through the grading document?
Not yet.
Okay, have you gone through the week one lectures?
Yes.
Yeah, ma'am.
Yes.
Yeah, that is good. So, like, grading will be based on, like, we will be having grading assignments, graded assignments, which will be of 10%. Graded assignments will be having 10%. And you will be having MATLAB sessions. You have to solve some problems regarding, you have to submit programming assignments. Do you have any idea regarding that? So you
No.
have So you should have this MATLAB grader in order to solve this programming assignments. So we'll be having these sessions later also. Like most probably, this MATLAB assignments will start from week third or week fourth. It will be starting. So that will be also 10%, and remaining 80% is of quiz one, quiz two, and NSEM. So quiz one is on October 26th. Quiz 2 is on November 23rd, and NSEM is on December 21st. Am I clear with this?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay.
Ma'am, is there any OPP? Because you said there will be MATLAB questions.
No, like you won't be having a OPP exam, but you have to submit the assignments in the time.
Okay, ma'am.
Yeah. So your week one and week two assignment submission is on October 5th. Do you know that?
Yeah, ma'am, we know that.
Yes, ma'am.
Yeah. So like let's start what is meant by signals. Can does anyone have any rough idea, anything regarding signals?
Then we have two types of signals, analog and digital. Analog is whatever is in real life, and digital what computer understands.
Yeah, that
Uh,
good,
For first,
superb answer.
first of all, signal is a function
Okay,
where
nice.
it contains a variable which is independent variable and like f of x, anything contains a
Mm, good, good students. Like now I am getting the energy to continue the session. Good answers. So like as you have said, signal is a function. So which will be having dependent and independent variable in it. So like if we take t as an independent variable, x of t will be dependent. So like signal is the function which conveys the information. Like it could be anything. The one which conveys the information is a signal. So in general, for example, I'm speaking right now. So this audio signals, this is of one kind of signal. We'll be listening to the sounds from the birds, and our heart is beating. We'll be having that ECG rhythm, everything. These all are signals. Like signals we'll find wherever we go, like even telephone signals. So can you give some more examples where we'll be coming across the signals?
Can you repeat your question?
So can you give examples like this where we will be having signals like this? I was giving some examples now in general, or it could be any kind of signal.
Input signal, uh, sorry, that is square wave,
Yeah,
rectangular wave.
square wave.
in
That
lectures,
type of
professor
signal.
going through the concept of audio equalizer, and there he introduced audio signals and
Yeah,
basically
audio
both
signals. Yeah, good. Any more
like
other
Communication
signals.
system,
yeah,
Sign every trigonometric function is a
control
signal.
system.
yeah, trigonometric. Or in I want in general, like some of your friends told like telecommunication signal like that, right? In general, you can tell. Like these are mathematical. The one you have told, trigonometric signals or square pulse, everything this comes under mathematical. So how I want to get is just I wanted to connect it to generalize so that you will get more involved in this.
So, ma'am, there would be many types. Like, if we use sensor and everything, then we will get signals from that also.
Yeah. True. Just
And
like
one the
from
signal that we got in our TV, that's also a form of signal.
yes. From the by using antenna, we'll be getting the signals right from
Yeah,
the
yeah,
satellite communication.
yes, ma'am.
And even we'll be using watches, right? Nowadays, Apple watches and smart watches have come. Like it is able to detect the heart rate, everything. These all comes under the signals. Okay.
Yes, ma'am.
So the signal it conveys the information and it is having the dependent and independent variables in it. So dependent variable is the one which will be depending on the independent variable. So independent variable examples will be like time. So it doesn't depend on anything, right? Time, distance,
Frequency.
yeah, frequency, etc. Coming to the dependent variable, it could be speed, it can be acceleration, etc. Comes under dependent variable because like speed is distance by time. It is depending on distance and time, right? Acceleration is dependent on velocity. I mean, indirectly, velocity is related to displacement and time, right?
Yes, ma'am.
Yeah.
So, just I wanted to clear with this. And now coming to the systems. So, do you have any idea regarding system?
System is a circuit which will do
No,
some changes in our signals or something like that.
or we
Yeah,
can say
good.
system is a box that processes an input signal and produces an output signal.
That's great, really. So, so systems are like will be providing input and will be getting some output, and there will be some transformation happening here. So this is responsible for transformation. If we give something to a box, so we'll be giving the input signal and the output will be getting the transformed one. Those are the systems. So let the input signal be x of t and the output be the y of t. So this is the transformed form of x of t. This is the system. Are you clear with this or any
Yes,
doubt?
ma'am. Clear.
Okay. And if you have any doubts, you are free to interrupt, you are free to ask. No need to hesitate. Okay.
Okay, ma'am.
So now, like I was telling, x of t is a signal. So, like, which is, it could be any signal, like sine t, or it can be cos, some square signal, etc. So here I'm taking t as a time as an independent variable. Time as independent variable. So, like here we will be considering as uh, so if we plot the sine signal, it will be looking like this, right? So I'm taking the example of sine. This sine t, it is 0. First, let's take it is 1, 2, 3, 4. Okay, it has to be -1, -2, -3. Sine omega t. So here we are seeing the positive values and negative values, right? So the one which is at 0 will be taking it as present one. Like at this moment, we'll be taking it t is equal to 0, it is at present moment. And 1, 2 are the advanced, I mean ahead. I mean this will be comes under the future. And -1, -2 will come under the past values. So it will, so this signal is of the past time and this will be of the future time. One is at 0 is a present time. at that moment what we are seeing. And coming to the types of signals. So here it is divided into two categories. One is continuous and discrete. So can anyone tell what is continuous or discrete? Any idea?
Continuous is where even given in just range there will be so many values, and
Hmm.
in discrete there will be different values at different intervals.
Yeah.
or, or you can say the values of the independent variable is a form of continuum.
Hmm. That is
Means it
continuous signal.
and it will have infinitely many time instance between any time interval.
Hmm. What is that second signal is called? Discrete, right?
Yeah, second signal is
Yeah.
discrete.
Yeah, yeah, good, good. So let me take one example here. What you have told is correct. Like what you are telling is correct. Like so, this is how continuous signal look like. So the signal will be in this form. So wherever we take the signal at any instant or time, you will have some value. Like for suppose it is at zero. At 0.0001, you will have some value at that point. Similarly, like at any place, it could be of 0.5 seconds, 0.005 seconds. So we'll have some value we can able to tell. So this is how continuous signals look like. Whereas coming to discrete signal, it will be like just a
It will
second.
have finite numbers of time samples between two time instances.
Yeah, it will be having finite number of the time samples. Good. So the same signal I have discretized it. So it is discretized at some interval. Like let's take it will be sampled. You actually the same signal. It I mean this signal I'm making it into discrete. So it will be sampled at regular time intervals. 2t, 3t, 4t, and so on. Minus t, minus 2t, minus 3t, and so on. So it where t is sample time period. So if we take 0.5t, we can't find any signal over there, right? I mean, at zero, there is something is there. At t, there is some value is there. But if we take of 0.5t or 0.0005t, we won't be having the values over there. So this is the discrete time signal. So like what to say? So discrete time, if we want to get the continuous time from the discrete time, we have to do interpolation. And there is one theorem also which will be coming across it, the Nyquist criteria. I mean, without loss of signal, how we'll be constructing? Like Nyquist criteria will be telling. And this theorem will be discussing in the further lectures. Just to just to introduce this term, I am letting you know. And for the in order to get the discrete signal from the continuous signal, what we have to do here?
Sampling.
Yeah, good. We have to do sampling. So here the sampling can be of two types, which is of uniform sampling. One is of non-uniform sampling. Like uniform sampling is like at equal time intervals we'll be doing the sampling. Coming to the non-uniform, we'll be doing in a not an equal. I mean, it could be a t, then later it can change to 3t. It won't be that uniform in non-uniform case. Am I clear with this?
Yes,
Yes,
ma'am.
ma'am.
Yeah. Any doubts?
Ma'am, could you please tell about the narcissist? Was it like that in which we have to make the we have to connect the dots in a way it would be like not like a line.
Yeah, like here will be Nyquist criteria you want to know, right?
Yes, ma'am. Just brief.
Okay. Okay, we'll take sine signal only. I'll be taking the example of sine. So I am taking I am sampling the signal like this. So here we may get triangular signal, right? For
Yes, ma'am.
this. Uh, Here if we do the interpolation, we are getting a triangular signal. But what I'm doing actually I'm doing for the sine signal. So what actually it is happening here is there is some lots of information is happening, right?
Yes,
I
ma'am.
mean, we are getting the triangular signal here. There is some loss of information. So we have to sample in such a way that uh, like so. Now you can able to reconstruct, right? This is a sample signal. Okay, discrete sample signal. Now if you draw the free line, you will be able to reconstruct the signal, right? Without any loss.
Yes, ma'am.
So here I will be taking another color. Now you are able to reconstruct the signal. So the sampling criteria, so we have to sample in such a way that uh, usually I will be telling on formula. So like sampling frequency should be greater than or equal to two times of frequency of this maximum frequency of the signal. Did you understand? We have to sample in
Yes,
such a way. In the previous slide, the sampling was like very less, right? One, two, three, four, five. Like per cycle, only five samples I have taken. here, right?
Yes, ma'am.
That's why there is lots of some information. Coming to here, like we have taken many samples, like it could be around 20, I guess, like roughly around. So it has to be, we have to sample in such a way, like it should be greater than or equal to two times of maximum frequency of the signal. Without, in order to reconstruct the signal without any loss.
Ma'am, I have a doubt.
Yeah.
So in real-time systems, if a signal is incoming, we don't know what frequencies are there in the signal, or in future what frequencies will be there. So how do you decide that what is the maximum frequency?
Like you are telling about real-time systems, right?
Yeah, like if I want to sample some signal and then reconstruct it, so a
Hmm.
signal is incoming, and it is going through a system one. So that the first system it is passing through, which is sampling the signal, is in system one, and then it is going to system two to get reconstructed. So
Hmm.
now if the signal that is coming, it is real time signal, then we
Okay.
can't know in advance what frequencies will be there.
Yes, good
So,
question actually. So, like in real time, you will be coming across this concept like Fourier series, Fourier transform. So here, what we'll be doing is like there are Fourier series, Fourier transform. You will be having Laplace transform. All these uh, things will be you will be having in the future lectures. So what their prime motive is they'll convert the time domain signal into frequency domain. Okay, like we'll be knowing what kind of frequencies are there in that particular signal. So if we take the sine signal, so it will be telling at one particular frequency what is a signal. Like here, if we take sine omega t, so omega is 2 pi by t, right?
yes, ma'am.
So omega will be here, like I have taken one. If we take omega as one, then time will be 2 pi, right? Time period.
Yes, ma'am.
So, like, if time is this, like, what will be the frequency? 1 by 2 pi. So, at 1 by 2 pi, you'll be having the frequency. I mean, like, when you will be converting, this is a time series, right? Time domain. Now I am converting into frequency domain, the signal. So, at
Yes.
that point, you will be getting the peak. Like, these can be, we'll be knowing all these things in
Yeah,
Fourier
yeah,
series.
got it.
Laplace transform, like in the real time signals as well. Like if you take some real time signal, audio signals, all this, if you take, when we pass a signal through this Fourier series, like usually it is for periodic, like for Fourier transform or Laplace transform, you will be knowing what kind of frequencies are present in that.
Okay, 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 ma'am.
You are clear with this, right?
Yes, yes.
And there are filters as well, like in order to cut off the signals, like at what frequencies there are low pass frequency. You would have, do you have idea regarding these filters?
Yes, ma'am.
Uh,
We are studying it.
Yeah, like so like here I mean there are types of filter like low pass filter, high pass filter, which will be allowing some certain kind of frequencies over there. Am I clear with the Nyquist criteria?
Yes, ma'am.
Am I clear with this frequency thing?
yes, yes.
Okay. And there is another classification which your friend has told, that is analog and digital. So analog signals are the real-time signals, and digital signals are the which computers understand. So analog signals, if we supply, I mean, if we give input as analog signal, we'll be getting the output as an analog signal only. If we provide analog, we'll be getting the analog signals. If we give the discrete digital signal as input to the system, we'll be getting the digital signal as an output. So, like how will be, let me tell why we are going from analog to digital. So, if we see usually you would have seen in the past, long ago, we tend to have cathode ray tube TVs, CRT TVs. The size will be very bulk, right? Now, if you see the TVs now, they are very thin. I mean, what I'm telling is these signals. So analog signals that are analog TV, right? CRT TV. Hello.
Yes, ma'am.
Yes, ma'am.
Yeah, you are able to get right what I'm telling.
Yeah, yeah, yeah.
Yes, ma'am. Yes,
Yes.
ma'am.
So you are able to see the transition from bulk TVs to the very small TVs. I mean, very thin TVs we are able to get now. And if we
Yes.
see long back, the computers tend to be of the entire room. It tend to cover, right? For the storage and everything. Now we are able to see in a very small thing. This is all because of we are because of this change. I mean, that's why we are going for the digital thing. Are you clear with this?
But ma'am, in in 1900s, the digital computers even was bulky.
Yeah, they're bulky. So now they have made it into small, right?
Yeah, so it is based on the which technology they use. So there they used some cathode ray tubes, and here they use some uh, MOSFETs,
Logic
and
gates or something they'll be using, no?
yeah,
Like flip-flops or registers for the storage they'll be using.
yes, yes.
Even there is what is that? Some Morris law or something law is there. Like what that law tells is that it will be so if you see the chips or what so if there is one big thing, they'll be making it into small by making it half. Some Murphy's law there is it is there.
Um,
So
I
are you
think
talking about Moore's law?
Moore's
There's
law I
one
guess.
Murphy's law.
Murphy's law only, right? Yeah, Moore's law
Ma'am,
uh,
Murphy's law is about some philosophical thing, I think.
okay, let me come back to you regarding this later then. So there is one law, what it will be telling us, if there is one bulk thing in the coming year, it will be made it into half. So the storage will be reduced by, I mean, the storage will remain the same, but the components accomplishing in this will be more. It will be twice. Okay, I'll tell you in some other day regarding this. So this unlock and digital will be making so how will be coming from unlock to digital? So there is a signal, unlock signal. So we will be sending it to the sampler. After sampling, what we'll be getting?
Time
Discrete signal.
sampled, time sampled discrete signal.
Yeah, discrete signal. So, so here this unlock signal will be continuous in time and continuous in amplitude, whereas discrete signal will be discrete in time but continuous in amplitude. So, like, we'll be at the end we'll be getting the digital signal. So here we have to do the quantization. So, so what this quantization is like, we'll be converting this continuous amplitude to discrete amplitude. Okay, by using a quantization by bits. So we'll be getting the discrete signal with digital signal, which is of discrete time and discrete amplitude. So this can be done by ADC converter. ADC, which is analog to digital converter. This all together, the sampling and quantization together called. Am I clear with this?
Yes, ma'am.
So we are making this kind of signal into like here we will be getting like this in the discrete, right? In the discrete, we'll be getting like this. So whereas coming to a digital, it will be sampled by bits. So if we take 4 bits means it will be 0001, 1011. So there will be 4 bits. According to that range, we'll be having that 0, 1, 2, 3. This is 0. This is 1. This is 2. This is 3. So based on that, we'll be having the range over here. So this is how digital will be like. So here we are saving. So here, if you see, in between, if we do the reconstruction, we'll be getting the signal back, right? I mean, here I'm taking the example. It could be either 4 bit or 8 bit or 32 bit. It could be anything. Based on that, we'll be doing. So, like, here we are able to save some storage, right? I mean, we are able to get the same signal, but there is nothing here. If we reconstruct, we'll be getting the same signal back. Are you getting this?
Yes, ma'am.
So we are removing some unwanted things by converting here. So that's why the TVs which are big now became small. Now are you able to connect it why it is happening? I mean, why the bulb TVs got converted to cable?
Is that because of this, or I mean, because of ADCs, or because of some the technology used in the ADC?
That it is because of technology also.
I mean, ADCs were there previously too. The bulb TVs were previously for digital TVs were there, but it depends. I think it depends on the technology used in the
Yeah,
digital TV.
technology. This is how it works. Like basic principle is this, and it is because of the technologies which is growing day by day. I have told one law, right? I don't remember exact name of this law. It
It's
start
Moore's
with
law. Moore's law
Moore's
only.
law. Okay. Can you tell it, Angita, like what is that Moore's law clearly?
Like when this semiconductor technology was building up, Moore predicted that like in every 18 months, the number of transistors in a chip will double. But like it initially this was true, but now we are kind of getting stagnated because like from we used to use BJTs, then we moved to these MOSFETs, CMOS, FinFETs, but now it is kind of getting stagnated.
Hmm. So, but the size will be reduced, but the number of transistors accommodated will be double, right?
Yeah, we will
Yeah.
reduce the size of our components, and that is why there will be more components in the same area, so more functionality.
Hmm. Thank you, Ankita. Are you clear with this? The one, it's because of technology and it's because of this. I mean, technology is growing.
Yes, ma'am.
Yeah. So now we'll be looking into the transformation or signals. So here we want to transform the signal. Like, see, if we are taking the example, like now the speed I am telling, it will be telecasted in the YouTube. Like, if we see in the 1x, it will be of the same speed. But if we keep it 2x or 1.5x, the speed will be more, right? And if we
Yes,
keep
ma'am.
it, yeah, if we keep it the 0.5x or 0.75x, the speed will be less. I mean, the same signal is we are transforming. So this is so so this is what like this is scaling, like what the example I have given, and shifting is another transformation. Other is reversal, like time scaling, time shifting, and time reversal. So before going into this, I would like to discuss some important examples like standard signals. So one signal I already discussed in the previous slide, like sine signal will be coming under this. There is delta signal. So delta signal is represented as delta of t. I mean, you no need to focus more on to the delta signal because it will be more detail in the week 3 or week 4. So it will be like infinity at t is equal to 0, and it is 0 when t is not equal to 0. So this is how the delta signal looks like. So when at t is equal to 0, it will be infinite, and other than this, it will be 0 in remaining parts. Are you clear with this?
Yes, ma'am.
Coming to the unit signal, or it can be step signal. So it will be like this. Like you are able to see like a step form, right? It is looking like a step. So unit means one. So unit step signal, it looks like this. So it is represented as u of t. So which is 1 when t is greater than or equal to 0, and it is 0 when t is less than 0. This is how unit step signal looks like. And other is a RAM signal. So RAM signal, you all know how the RAM look like, right? This is a RAM signal. So it is represented as r of t, which is equal to t when t is greater than or equal to 0, and it is 0 when t is less than 0. So this r of t, there is some relationship between a delta of t and u of t. The relationship between this is u of t is integral of 0 to 0 to infinity delta of t dt. The relationship between delta t and u of t, and r of t and u of t, it is 0 to t u of tau d tau. Why I'm keeping here tau is like it could be like in order to differentiate from this t to this tau. I mean, if we, it could be anything. Like you can keep 0 to t u of x dx. Like the resultant will be same. The even if the variable changes, the resultant result will be and the final result will be same. So this is a RAM signal. Are you clear with this? Right?
Yes.
Yes, ma'am.
Yes.
And other signal is rectangular signal. Am I boring?
No, ma'am.
No, ma'am.
So rectangular signal is rect of t, and I so this lecture is important lecture because based on this lecture only you will be knowing the coming things, right? This is a foundation. I mean, foundation to the next concepts. So you have to be in thorough with this. So it will be the standard rectangular signal will be from minus half to plus half. So it is 1 between minus half to plus half and 0 otherwise. And other signal I was telling, there is a triangular signal as well. And sine or cosine signal, etc. These are the standard signals. So I was telling about the transformation of signals, right? So time scaling, I have discussed regarding this, like regarding the speed. So before that, I would like to tell like time shifting. So if we take the signal, the same signal which I was telling before. So here there are two things are there. One is time delay and another is advancing of the signal. So time delay is like we are delaying the signal by t naught units. So if we take it as some 20 minus 20, if we delay the signal by minus 10 units, so it will start after 10. I mean after 10 seconds, after 10 units, that signal will start. So after 10 seconds means it will be 10 only, right? So it will be shifted towards right. So this is a time delay. and it is shifted towards right. Shifted towards right by, here I considered as 10 units or T naught units. If there is minus means it is delayed signal. And the same signal, if I advance it by the 10 units, so here we'll consider it as like 20. Okay. So here it will be, since it is delayed, here the last point will be 30. So the same signal, if I am advancing it by T naught, here I am taking the example as at plus 10. Now can you tell from which point the signal will start?
Minus 10.
Minus 30.
Yeah, good. So this is how the actual signal is. So at minus 30, the signal will start. And where the signal will end?
It's 20.
Sorry?
10.
10, 10.
10, 10.
Yeah. Good, good. Really good students. So at 10, it will end. So we are advancing the signal here. So it is shifted towards left. So it is time advancing. And it is shifted towards left.
Ma'am, how this advancing works in real life?
In real life, okay, like if we see the recorded videos, see now I am telling at this instant, right? Now I am explaining no. At this time we can take this signal and some of the students have went joined the session, right? So they will be watching the session after some time. Means once I end the session, they will see. I mean now already it got finished. The session got finished. Now they will be seeing this no. After finishing that, you are able to get it what I'm telling.
Mm,
In the
yeah.
YouTube, okay.
So,
So
ma'am, for doing this, the system, whatever it will do, it will only do in storage if the signal is already stored.
yeah, the stored signal only. Yeah.
Okay.
Yes. So like uh, so now let's take like from the beginning onwards. I am telling no, like from 9 o'clock I have started the lecture now, which has become the past now. So I am like take the signal which is this. Like at 9 o'clock I have started the lecture. Now it is 10, like present. So maybe within 10 minutes I'll be concluding at 10:10 we'll take. Or like since we have taken here minus 20, here 20, we'll take it as 11. Okay. So now this is a present scenario. Now later, like your friends who haven't joined, like they will be seeing the session in the YouTube, right? With the same speed. If they see at 1x, they'll be seeing at the once I end, they will be seeing after some time, right? So it is like I'm telling the analogy. So it is the delayed, I mean advanced one. They are seeing the session once I finish it, right? Are you able to get it?
Yes, ma'am. I'm not
So,
very clear.
so you want, so your question is where we are using this shifting.
No, ma'am, I mean, like, what is this advancing? How?
Advancing is like what? Advancing is like we are moving the signal ahead of the present. This is the actual signal, no? This minus 22 20. This is the actual signal, right?
Yes, ma'am.
So we are advancing the signal means it has shifted by 10 units, which is advanced by 10 units. So it is from minus 30 to 10. So it has moved ahead of the thing, right? Ahead of the present. So like what t is equal to 0 tells, it is at the present moment it tells, right? It is a time at the present moment. So it is ahead of the present.
Okay, ma'am.
Are you clear? No?
So, ma'am, the delayed, we can watch the delayed signal. I mean, if we are watching a delayed signal, then we can without storing it, we can watch. But for a advanced signal, we need to like store it first, and then we can watch like
Yeah,
that.
yeah, yeah. It is like stored one, like plus T naught is. Of
Okay.
the recording, you will be seeing, no?
Yes.
Actually, like some of your friends will be live streaming from the beginning at this time.
Yeah. In a live stream, we can delay
We can
the
go back,
video.
right?
Yeah.
We can go back and they will go and check it. We
No,
at that,
I was thinking that even if the stream is live and we
mm,
are watching at the live moment, whatever they are doing, we can delay
mm.
it, but we cannot advance the live stream because we
Yeah,
don't
we
know
can't
whatever
go
will happen
later.
in future.
What is happening next, we can't see. But we can
Yeah,
see the past thing, right?
yeah, yeah, yeah.
That's what I meant. Now, am I clear
Yes,
with
ma'am.
this?
Yes, ma'am.
Okay. This is a time
So can
shifting.
we say, that we can realize the signal system while comparing with the video and audio in any YouTube video like that?
Uh, Sorry, come again.
Can we just like what to say, realize the signals and systems by comparing it with the YouTube video like that? Like moving in
Yeah,
2x
like this
makes
is
the
an analogy I have given.
okay.
There are many instances, not, I mean, like, this is an example for comparison, for your better understanding.
Okay, ma'am.
Okay. So, other is time scaling. So, here you have to focus on minus and plus. So, minus means it is shifting towards right, and plus is shifting towards left. Okay.
Yes, ma'am.
You have to focus on this more. And coming to the time scaling, so here time scaling is like we will be, I have told it 2x speed, no? Like, so I will be taking, so let x of t be the original signal and x of at is a transform signal, okay? So, so there is a possibility of the signal to expand or it can compress based on the value of a here. So if a is greater than 1, then the signal is compressed. If a is less than 1, modulus of a is less than 1, then it is
Expand.
expanded. So here, like I was telling this no YouTube video, if it is 2x or 1.5x, so the speed will be increasing. So the length of the duration will be decreased, right?
Yes, ma'am.
Yes, ma'am.
So it is compressed. So if we take it 0.75x or 0.5x, So it will be very slow. So the length of the signal will be expanded. So like when it is less than 1, it will be the expanded signal. Now you are clear with this.
Yes,
Yes.
ma'am.
And there is another special case, that is time reversal. So what if A is less than 0? That is A is negative. What is if A is negative? Then the signal will be reversed, right?
Uh, yeah, it will be like a mirror.
Yeah, it will be like a mirror about y-axis.
Yeah.
That is when A is equal to -1. It will be like a mirror about y-axis. And here I wanted to tell one more, I want to add one more point. So here this compression and expansion is happening, no, in this case. It is happening about the origin. So if you take a signal, okay, we'll take a this rectangular signal -1/2 to 1/2. Okay. So now I am doing rect of 2t. So rect of 2t, whether it will be the compressed or expanded signal
Compressed
by how many times?
two
Two
times.
times.
So what will be the duration?
It will be
You will
minus
get
one
half.
to one.
It is
Sorry,
compressed, right?
minus one by
minus 1
minus
to
one
1.
by four
Minus one
to
by
one
four
by
to
four.
1/4.
Yeah, it will be -1/4 to 1/4. So it is compressed. It will be compressed along this origin. Okay. It will compress along the origin. So this is the original signal. This is how it is compressing. So rect of t/2. Now tell me what will be the length of the signal from where to where. You have to multiply here by 2. No, I mean it
Yes,
will be
ma'am.
the expanded one. So
Minus
it
one
will
to
be
one.
from -1 to 1. So it will be expanded along the y-axis. I mean about the origin. Are you clear?
Yes, ma'am.
And one more thing, what I'm telling here is this 2t and t/2, they all are happening in the time duration, okay? But amplitude remains the same here. In this case, amplitude remains same. But if you take like, if we take here it is 2, I mean 2 times of rect 2t, then the amplitude will be increased by 2. So here it is 1, right? Now here we'll be having 2. Now amplitude is changing. Like you got it clear, right?
So the yt needs to be multiplied by a or b or something.
Sorry. Here I'm
The
multiplying. Ah,
yt, y of t, the output signal.
yeah, output signal need to be multiplied by 2.
Yeah.
So then only the amplitude will increase. Now you are clear, right? Like usually these are time scaling, what I told. Like here is also this is happening related to the the shift is happening in time domain, not in with respect, but the amplitude remains the same. You are clear, right?
Yes, ma'am.
So this is, if we take, this is the x of t, the signal is x of t minus t naught. If it is x of t, the signal is x of t plus t naught. So it is happening with respect to time. And coming to the time reversal, one example I would like to discuss is RAM signal. So this is how it is x of t. If we do x of minus t, it will be reversed like this. Exact mirror, exact mirror opposite. This is of x of minus t looks like. And if we take x of 2t, so for the RAM signal only. Now the how now you have to tell like how the signal be like. So this is the original signal. Will the signal be like this or the signal will be like this? Can you tell?
The yellow one.
Yeah, good. This is the correct because it will be compressed, right? Here 0. For 1, it is 1. For 2, it will be 2. No? So it is 1 here. When it is 1 here, here we'll be getting 2 for the yellow one. It is compressing. So it has to compress. I mean, this since are you
So
clear
this
with
is
this?
compressing the x-axis,
Yeah,
the
we are
parameter.
compressing along x-axis, not
Hmm.
along y-axis. So if it is 2 here, here we'll be getting 4. We are clear with this?
Yes, ma'am.
Yeah.
So we can also see this like in xt, the slope was 1. And in x of 2t, the slope of the ramp signal is 2. So which slope is more? Yellow one. So that is why.
Okay, okay. Thank you.
Okay. Should I continue the session?
Yes, ma'am.
Yes, ma'am. Yes.
Okay. And I will be discussing. I am running out of time, so I will discuss like one more concept, which is like a combination of this transformation of signals. So now we have discussed about these three things, no? Like shifting, scaling, and reversal, right? So I'll be discussing about the combination of this. That is time shifting plus time scaling. So let's take one example. So, uh, okay, we were discussing about the RAM signal, right? So now I'll be taking R of 2t plus 1. Okay. Now how this will be represented? So usually R of t will be like this, right? For 0, it will be 0. For 1, it will be 1. For 2, it will be 2, right? So here we can do, there are two ways to do this. One, first, first way we can do, the easy way is first we have to shift the signal. And second way is scaling the signal, time scaling the signal. So here we have to shift the signal by 1 unit Towards here it is plus, no? Towards which side we have to shift?
Left.
Left.
Correct. Good. Towards the left side we'll be shifting. And then we have to scale the shifted signal by scaling it by 2 times. That is compressing. We have to compress the signal by 2 times. And the second way is first we can scale the signal. So we have to compress the signal by 2 times. Compress the signal by 2 times. So then it will be R of 2t, right? Then we have to shift the signal. So here, how we will be doing is, since it is R of 2t, we want to get R of 2t plus 1. So what we have to do? We want this signal now. So we have to do R of
We can
2
do
times,
r of t plus 1 by half.
yeah, 1 by
1
half.
means half plus half.
Yeah, this is what we have to do, right? Am I correct?
Yes, ma'am.
Yeah, this is what we have to do. So it is like in these two ways we can do, but the better way and simple way is this one. So now we'll do that. So we have to shift the signal by 1 unit. So the signal will be starting from
Left.
-1, right? So it will be starting from -1 and at 0 it will be 1. This is R of t plus 1, right? I mean this step is done. And the second step is now we have to compress the signal. So we have to compress the signal by 2 times. So from where the signal will be starting?
Minus 0.5.
Yeah, good. From minus 0.5 it will start and here it will be 1 at 0
Yes, ma'am.
because we are compressing along origin, right?
Yes, ma'am.
So at 1, what will be your answer? At 0.5?
Yes, ma'am.
What will be the answer at 0.5? At t is equal to 0.5,
2.
it will be 2. Good. So here you can check. So when we substitute here, R of 2 times of half plus 1. So R of, I mean here we'll be getting 1 plus 1, R of 2, which is equal to 2. So at 0.5 we'll be getting 2. You got it clear?
Excuse me, ma'am.
Yeah. 1 second. I'm telling.
Could you please repeat this last step, the compression part?
This part. So
Yes,
like we
ma'am.
have to compress it now. Compress it by 2 times, right? So
Yes,
here,
ma'am.
uh, like where it will start, we will be compressing about the origin, right?
Yes, ma'am.
So like so it should not be -2. This is confirmed, right? If it is -2 means it will be expanded. The other thing is, so we have to make it half. It is -1, no? We have to divide by 2 in order to compress. So it is 0 -0.5. It will be starting at -0.5. Uh, are you clear till this point? Hello.
So, ma'am, you're taking the half, right?
Yeah,
for
we
the
are
compression.
compressing. No? Yeah, yeah, yeah.
So is it first the scaling and then sifting, or it's a sifting and then scaling, right, ma'am?
First we are shifting, then we are scaling. I mean, here I have discussed about two steps, right? One is first we will be doing the shifting and then scaling. And another way is we can scale and then shift. So first I am doing this easy one. Like first we are shifting, then we are scaling.
Lavanya, you can add now more points in this R of t plus 1. So maybe then it will be more clear. Like after
Ara?
0, you can show 1, 2, and so on. The
Okay.
second one.
Okay, here you are telling.
Yes, yes, yes.
So here one means here we'll be getting two, right? So okay, this part is clear, right? R of t.
Yes, ma'am.
So like here t plus 1 we are doing. So we are shifting it towards the left. So the signal will be shifted. So if we take at t is equal to 0, we'll be having r of 1 at t is equal to 0, r of 1 which will be 1. So it will be 1, right? At t is equal to 0. I'm substituting in this. This is a shifted one, right? Then I'm 0 plus 1. I'm in the place of t, I'm keeping it as 0. Like I want to see at at time t is equal to 0, what is the value? So it is r of 1. So like from the RAM signal, r of 1 is 1, right? So it will be 1 here. At time t is equal to 0, it is 1. Are you clear with this
Yes, ma'am. The shifting part is clear. I'm trouble in compression.
scaling? Oh yeah, I'll come with I tell regarding that as well. So uh r of at minus 1 also you are clear, right? Minus 1 will be getting the
Yes, ma'am. It's clear.
and 1 will be getting the 2 and at 2 will be getting the 3. This is clear. So now we have to do the scaling. So we will be scaling by 2 times. We are compressing. Compress by 2 times, right? So uh the thing is it is compression that is clear. So some people will be confused whether the next point is minus 2 or 0.5. They'll be confused, right? Because we are scaling it by half. I mean, we are compressing to, we are compressing it, no. So it has to move towards this side. So the next point is minus 0.5. Are you getting this?
So we will always consider with the not the
With the, okay, you substitute, okay, R of 2t plus 1, right? The this thing. So R of 2 times of, we'll take minus 2 plus 1. Okay. So R of minus 4 plus 1, which is R of minus 3. So R of minus 3 is 0, right? So at minus 2, at time t is equal to minus 2, it is 0. It by, I mean, like I have substituted in place of t minus 2, I have substituted. So it will be 0. Now another case is, so till when it will be 0? It will be 0 till minus 0.5. So when I substitute, minus 0.5 is half plus 1. So it is, this get cancelled, it will be minus 1 plus 1, which is r of 0, and it is 0. At 0. At minus 0.5, it is 0. And if we take at t is equal to 0, which is r of 1, at t is equal to 0, we are getting 1. Are you clear now?
Yes, ma'am.
Or do I need to repeat it once again? Should I repeat it or are you clear with this? Or does anyone have doubt here? Can I proceed further?
Yes, ma'am, you can
Yes,
proceed it.
ma'am.
It's clear now.
Yeah, it similarly, like if we take it 0.5, take r of 2 times of 1 by 2 plus 1. So it will be r of 2. So at 0.5, we will be getting 2. So this is compressed, right? I mean, where we will be getting, so this is a compressed version of this. So this is a easy way. Now we'll see the another tough way. So actual signal is r of 2t plus 1. So first we have to scale. So this is r of t. Then r of 2t will be, like, we'll take 1, 1, 2, 2, right? So r of 2t will be, it will be compressed. Now you tell at 1 what will be the value.
1 by 2.
At 1 it will be 1 by 2. Think properly.
No, no, I was telling about the 1. It will be 2.
It will be 2, right? You substitute here. So it will be r of 2, which will be 2. So at 1 it will be 2. I mean it is compressed, right?
Yes,
At
ma'am.
0.5 it is 1. So this is how r of 2t looks like. Then we have to shift by half. I mean, now we have to shift by half in order to get r of 2t plus 1. In place of t, we will be keeping t plus half. Are you clear with this? In order to get this is our final goal to reach. So r of 2 of t plus half will be doing. So we have to shift, I mean, we have to shift towards left, right? Because it is plus here. So we will be shifting the signal towards left. So by how many times we'll be shifting? By half units. So it will be 0.5. So it will be 0 over here. At 0, what will be the value? At 0, it will be 1. At 0.5, it will be 2. Are you
2.
clear?
Yes,
Yes,
ma'am.
ma'am.
So uh, the easy way, uh, so usually first we'll be doing the shifting. Second, time scaling. And if there is reversal operation, for suppose if there is uh, for r of minus 2t plus 1, if there is the question like this, then we will be doing the time reversal later. This is for the easy way I'm telling. So here, we have done the shifting. Now we have to do the reversal, right? So So R of 2t plus 1 is looking like this, right? 0.5, 0. Sorry, here it is minus 0.5, 0.5, 2. So R of minus 2t plus 1, we have to reverse. So now you tell where the signal will end. We
What?
have to reverse. Come again.
And from minus infinity to minus zero point 0.5, it will be a decreasing graph, and then it will be 0.
It will be 0 at what point?
Minus 0.5. After is minus
No,
0.5.
no. At 0.5, it will be 0, not minus 0.5. It is a decreasing graph, that is correct. But see, we are reversing it, no, here. We have to reverse along, it should be the mirror
Okay,
Mirror
okay.
image
opposite.
across the y-axis.
So, negative along the, we'll be taking this as a mirror, right? So, what is the reverse of this at 0.5? So, this
Yes.
0.5, it will be 0 and it will be decreasing. This is how it looks like. Now you are clear with this?
Yes, ma'am.
Yeah. Like you have to get more thorough with this, and you will be having problem solving session on Monday. Thank you. This is what I wanted to discuss for today.
Thank you,
Any
ma'am.
more?
Ma'am, can you solve two activity questions?
Will you provide me now?
Yes, ma'am, I can.
Which question can you can share the screen?
Yes, ma'am, give me a minute.
Like all the questions you are asking, or the doubts
No,
you are.
ma'am, one question specifically.
Okay, you can share the screen.
Yes, ma'am, give me 1 minute. I'll open it.
Okay.
And I repeat, please try to watch all the lectures of week 1 before Monday.
So peer review is like your friends. You have to submit the handwritten solutions. Like one of your friend, Uma Shankar. So you will be submitting the handwritten solution, right? So you will be given to your friend. I mean, one of your classmates to review. So your things will be exchanged and they'll be allotting the marks. Uma Shankar, am I clear? Yeah, there is also project. So it will be taken care by the professor. You have to do the project. For more details, so project allocation, I am not sure. I'll get back to you when it will be provided. So it will be taken care by the professor.
Ma'am, it's the question.
Okay.
I found the function of this. It was coming as root 2 sine 2 pi t plus pi by 4.
Sorry, one second, 1 minute. Yes,
It was coming out as root 2 sine 2 pi t plus pi by 4 when I
third
solved.
question I'm telling you now.
Yes, ma'am. Yes, ma'am.
Uh, so x of t is cos 2 pi t plus sine 2 pi t.
Yes, ma'am.
So you have to plot the signal, right?
Yes, ma'am. I have changed it in one wave, and I was not able to plot the signal.
Okay, like uh, yeah, like you can take right like cos zero. I mean, like a t is equal to zero. Okay, I will take this. Just a second. Cos 2 pi t plus sin 2 pi t, right? Can you stop sharing the screen?
Sure, ma'am.
So the question is cos of 2 pi t plus sin 2 pi t. Correct?
Yes, ma'am.
So like we'll take cos t is equal to 0. So cos then this term will be 0, right? Sin 0. So this is 1. I mean cos 0 degrees is 1. Sin 0 is 0. Correct? So as a result, at time t is equal to 0, this complete expression will be having as 1, right?
Yes, ma'am.
So at 0, we'll be having this and we'll take at 30 degrees, that is 2 pi. Okay, t is equal to 1. Okay, we'll take it half sine 2 pi half. So it is cos pi plus sine pi, right? So what is cos pi radians? Minus 1.
Yes, ma'am.
It is 0, right? So when t is equal to half, if you compute this expression, we'll be getting minus 1, right? Am I correct?
Yes,
As
ma'am.
0.5, we'll be getting minus 1. So if we take t is equal to 1 by 4, so it is cos 2 pi 1 by 4 is 5 by 2. Am I right?
Yes, ma'am.
Then here also we'll be getting 5 by 2. So this is 0 and this is 1. As a result, we'll be getting 1. At 1 by 4, that is at 0.25, we are getting 1. Am I right?
Yes, ma'am.
Can you show the plot once?
Okay,
Now
ma'am.
can
You
you?
can take a screenshot. I'll send it to you. Ma'am, what I did is I changed this two thing in one sine wave by applying some
Yeah, you can
formula,
do that as well.
and I got root 2 sine 2 pi t plus pi by 4. And after when I
Okay.
was yes, ma'am.
Then you have to substitute, like you have made it into single term, right? Single
Yes, ma'am.
expression.
So
So
now
what
that
you have,
you have done this, you can do scaling and shifting and
yeah.
amplitude change, and then see what do you get.
Yes, ma'am. I tried doing that, but I was getting something wrong. That's
What are you getting?
why. I was getting the second plot.
Second one. Maybe you can try again.
Okay, ma'am. I'll try it again, and if I'll be not able to solve it, then I'll send it on GSpace.
Yeah, you can share it there. Like you have converted into one thing, right? So like you just do the amplitude scaling and